Okay, so this video is going to show a couple techniques for how to use algebra to simplify first and second derivatives. This is our original function. Suggestion is to not use the quotient rule when you don't have a variable in the denominator, rather rewrite it with a negative exponent, and then just use the power rule, followed by the chain rule. So reduce the exponent by 1, multiply by the derivative of the inside, which is 2 minus 2v. And if you want, you can factor out a negative 2 from here, which will negative 2 times negative 8 gives you this 16. And then this becomes a v minus 1 instead of 1 minus v. So there's your first derivative right there. Now we can use the quotient rule. Okay, so we've got the denominator times the derivative of the numerator minus the numerator right here times the derivative of the denominator. Well, the derivative of the denominator, power rule. Move the 5 down front, reduce the exponent by 1, multiply it by the derivative of the inside, the chain rule, all over the denominator squared. So this thing squared makes this exponent a 10. Now here's the key. Notice that each term in the numerator on either side of this minus sign contains 2 plus 2v minus v squared to the 4th power, and it contains a 16. So you can factor out that GCF. That's what I did right here. And what remains on the inside? Well, from the first term, I just have a 2 plus 2v minus v squared. From the second term, well, this 16 is gone, and this is gone. So I have a minus 5, and then I've got a v minus 1. While I'm at it, I'm going to factor out another negative 2 from here and rewrite this as negative 2 times v minus 1. And on the next step, this factor right here cancels out with 4 of these factors in the denominator. That's why that became a 6. So all that remains is to simplify what's on the inside. This, of course, minus 5 times minus 2 becomes a plus 10, and I got a v minus 1 quantity squared. If you square this binomial, distribute the 10, combine similar terms, you get something like this, where every term has been multiplied by 3, but you can factor out that 3. 3 times 16, 48. So there you go. There is the second derivative. And here's kind of a way to prove that on Desmos. Okay, here's the original function. Here's q prime, or q sub 1, using the Desmos derivative operator. Here is p sub 1 is the answer that we got. And if I copy in what these graphs look like, here's the graph of the second derivative. It's a little bit smaller. By enabling Q1 and P1, you'll see that the graphs are identical. So that kind of proves that this answer is correct. And similarly, when you get to the second derivative, if you enable both of these, Q2 is the derivative of P1 or Q1, either one, and P2 is the answer that we got. Those graphs are identical. So you can go to Desmos. I'll give you the link to this graph, and you can play around with enabling these to see that that indeed is the answer. There you go. Hope that helped. If you have any questions, post a comment.